Okay, so this is just in case you are working with something that it's not the Revit file. So I will provide you, first you have to let me know. Then I will provide you with this file, with this building, and then you have to work with these three spaces. The first space is the lobby, the second space is this auditorium, and the third space is this restaurant. So I have copied and pasted this lobby on the Excel file. And now, if you let me know, I will provide you with this file and the occupancy, because I want each group has a different occupancy. Okay, but let's say that this is 300. So we have 300 people times 20 CFM per person. So it's 6,000 CFM. Then divided by 25 diffusers, because in this lobby we have 25 diffusers. So each diffuser is 6,000 divided by 6,000, it's 240 CFM. Okay, so each diffuser, each supply diffuser, it's 240 CFM. And now we have to start drawing this. So if you copy this, so this is this can be a diffuser. So we can place it here. This is 240. And as you can see here, we have a branch with two diffusers. We have two. So we can do this. Let's make it pink. Okay, so we have 240 here and 240 there. So we can copy this here. Okay, 240 and 240. And then we have the central branch. So the central branch can be something like this. So what is the diameter of this diffuser here? We can copy one of these tables. Here. Okay, so what is the flow? This flow is this plus this one. So it's, we can say that it's this value plus this value. Okay, so this is 240 to 40, so the total is 480. We want this velocity to be around, between 200 and 600. So 1 inch doesn't make any sense. Let's make 12. 12 is too high. Well, it would be good. 600, it's not bad, but 14. I don't know why, but we always have even numbers. Okay, we don't have odd numbers here. It's always even. We have 14, 12, 10, 14, 20. We don't have 13. I don't know why, but usually we have even numbers, 8, 10, 12, 14, 16. So 14 is enough, and now the velocity is between it's within this range. It's good. So now we have the second branch here, so we can just copy and paste all this here. Okay, the problem is that now the flow here is the flow that comes from this. It's 480, 240, and 240. So this is plus this one. Okay, so this is 960. It's 480 plus 240 plus 240, 960. Now 14 inches is not enough because the velocity is too high. So we can change this to 18. Yeah, with 18, we are below 600. So that's good. And now we just can keep on copying this. How many times? 1, 2, 3, 4. Okay, so let's do it. And if you do it, okay, so now this flow is this one plus that one. And this flow is this plus this plus this. That's fine. And finally, because here we have 4 branches, 1, 2, 3, 4, 1, 2, 3, 4, and we have the 5th here, but we have a horizontal branch in this direction. So probably we have to go this way, and then we have to go all the way there. And here we have these 200 and 240, 240. So we can copy this. And we can copy this one here. But now this, it's only this plus that one. This is for 80. 18 is too much because the velocity is, so this can be, I think it was 14. So this can be 14. And now what about this one? This branch here, what is the flow? The airflow is this branch plus that branch. Okay, and here 18 is not enough, so probably we need 22, 24. Well, this is not, 18 is not enough here. Okay, so this is getting bigger. And this is what we see here. So we see that the circuit, as we are adding branches, the duct gets bigger, bigger. Okay, so if 24 is not enough, we might say that it's 30. Yeah, 30 works. Okay, so this is it. And now you have to add this branch here. So in these branches, we have 3 diffusers. Each row, we have 3 diffusers. Here we have only 2. Okay, so at the end, this main branch has to be the thickest because we are adding all the branches here. So the flow here should be at the end of this branch before just the vertical, the CFM should be 6,000 because this is the total CFM here. Okay, so this is what you have to do. If you can't access Revit or whatever, you have to work on this Excel file. And at the end, well, this is what okay, so this is what you have done. And well, you have completed the 3 spaces. So I think it's good. Yeah, so this is what I expect from. The thing is that if you are doing this, now you have to prepare a report. Okay, so you have to prepare a PowerPoint. And on this PowerPoint, you have to copy and paste this one. And then I need this here. There you go. Nice. So I can see the drawing itself. And here I can see, I can check that all the velocities are below 600, between 200 and 600. I think all of them, well, maybe this velocity is too low. If the velocity is too low, we can make it smaller and we will save money for our clients. Anyway, but this is what I want. So I want the picture of the space that you're analyzing, and this is the analysis with the Excel file. So at the end, I need a report like this instead of the Revit file. And what else? Oh, here, I think I gave you some feedback. Well, you have not calculated the graphics with this. So if you have included the 50%, by the way, this is from Monique, Grace, and Hannah, okay? So you have, if you are working with this, the highest number here is 195. Yeah, 195 for 60. Okay, so this one, it's not 197, what? No, it's 195 for 60. Yeah, I made a mistake here. So this is 195 for 60. Okay, so this is the highest value of cooling loads with the heat recovery. That's fine. And then I need, okay, if I go over this, the thermal load, the watts, the electrical load is this divided by the, yeah, so that's correct. And then each classroom, yeah, calculated, yeah, so that's correct. Oh, and by the way, there's something that none of you have done so far, because we are requiring a schematic of heating and cooling system. Okay, so the schematics of the heating and cooling system basically is what we have in this file. Okay, so here you have, well, I told you that you have to complete this as other students have done, so you don't have this branch for the last office space we have here, but everything else is correct. So what do we have in this, in each classroom or in each office space? So we have ducts that come from the air handling unit, and then we have a split system with the heat pump, the outdoor heat pump, and the indoor split system unit. So the schematics has to be something like that. Okay, so we have an air handling unit. The air handling unit, the heating coil is connected to a water heater. So if you look at the, yeah, so one of the water heaters is connected to the heating coil of the air handling unit. Then the chiller is connected to the cooling coil of the air handling unit. Okay, so we need the chiller, and this chiller has to be connected to the cooling coil. And then we have supply and return. These are the air ducts. And finally, we have the split system. So we have an outdoor unit, and it is connected to this indoor unit of the split system. I know I don't like these schematics because it's not well organized. There are a lot of intersections and it's not clear. But those are the elements that you have to include in these schematics, because they are the same elements that you are including in the Revit file. Okay. We have to be able to understand the information in different formats. So this is a schematics, but we are conveying the same information with the Revit file. The Revit file is better because everything's here. But if we look at this, it's a mess. So if you try to, if you print this view, it's nice, but it's confusing. So if I want to convey what I'm doing in so that everybody can understand, so this is better because I'm analyzing here only just a classroom and an office space. So we need both. Okay, so this is like an abstract idea of what I want to do. Basically, I have the elements and I'm connecting elements. I cannot connect the chiller to this, or I cannot connect the chiller to the boiler. So it doesn't make any sense. So we need to connect, we need a supply, we need a return. Okay, so that's why we have the dashed and the continuous lines. I have to differentiate between air ducts and pipes, water pipes. But we need both documents. We need this, and then we need the 3D view, and we need plans as well. Okay, so the 3 documents, if we are working in a company designing mechanical systems, first I need something like that, then I need plans, and finally, you don't have to print the 3D view. You just give this file to the architects or to the structural engineers or whatever, and you say, okay, this is the mechanical system. So now you try to integrate the structural systems, and if there are any conflicts, get back to me. And then this file, okay, so I am designing these columns, and I have a column here. So you have to move this duct because there's an intersection between the column and the duct. Okay, so who moves the you structural engineer? Can you move the column, or is it easier that the company that are working with the mechanical systems move the ducts? So this is, if we are all working on or if you are working with the same building and you are the only one working with this Revit file, it's easier. But if you're on a multidisciplinary team, there are a lot of conflicts, and Revit can help us prevent those conflicts from happening on site. Okay, because when we were working with these kind of files without Revit, yeah, everything's here. We have the structure and we have these intersections. So how can we deal with these intersections? I don't know. Someone will deal with it on site. Okay, with Revit, we can foresee the conflicts that we can have. So there are a lot of intersections here. So what happens here? We don't know.